Welcome to Hidden Treasure Educational Consultancy Services. Today we are going to continue with normal grade series, and the topic there is Indices and Logarithm 2. In our last episode, we really talked about laws of indices. Laws of indices. Recall that the laws of indices are: number one, x raised to the power a times x to the power b is equal to x to the power a plus b. X raised to the power a divided by x to the power b is equal to x to the power a minus b. 3, x raised to the power 1 over a is equal to a root of x. 4, x to the power b over a is equal to a root of x, all raised to power b. And number 5, x raised to the power 0 is equal to 1. Then number 6, x raised to the power minus a is equal to 1 over x raised to the power a. 7, x raised to the power a all raised to the power b is equal to x to the power a b. Remember we said that combination of 1 or 2 here can extend the laws of indices, even up to 15 laws. However, normal grade series is a series that we teach with the scheme of work or the syllabus of grade 10, grade 11, grade 12 we have in many high schools. So we are mindful of this school. Alright, before 1, 2, 3, 4 to 7, the 7 laws here can be used to simplify calculations involving indices. As we said before, to solve equations involving indices. Some people would ask, when do I know that is expression or equation? A question like this that doesn't have equal to sign is expression. A question like this that has equal to sign and we have a letter we are looking for is equation. In other words, in all equations, we are meant to find the value of unknown in that particular equation. A question like this is also an equation. It has something we are looking for and it has equal to sign, showing that it's an equation. But there's no equation in simplification questions. That would say simplification or evaluation or find the value of, whichever way they ask the question. We know it should be to do it using what we see there. If it's decimal, we use decimal, but in this case, we are interested in indices. Remember that we are going to use all these laws now to work the questions we have on the board and come out with the correct answers. And that's what is expected in this topic. We are going to solve this now. Let us start from simplification. Yes, in logarithm and indices, number 1, I was giving you examples that had only one number, like 8 raised to the power 1 over 3, as just a question. However, as they say, every day cannot be a Christmas day. So questions set by examination bodies may not be as simple as that. Let us solve question number 1 using laws of indices. Solution to the question. Solution. We have 8 raised to the power 1 over 3 times 16 raised to the power 3 over 4 times 31 raised to the power 0 all over 4 raised to the power 1 over 2. Alright, with this question here, we will start solving this way. We will start solving and then we take it this way. We know that whenever we have over, the number we have under the denominator is the number that is dividing the rest, the numerator. And so we can write this as 8 raised to the power 1 over 3 times 16 raised to the power 3 over 4 times 3 31 raised to the power 0, then divided by 4 raised to the power 1 over 2. What it means is that this 4 raised to the power 1 over 2 is dividing the whole of this. And remember that when we have division sign, we can change it to multiplication. Alright, let us use this law number 3 to work on this. So that the law number 3 here, using to work on 8 raised to the power 1 over 3 alone, is going to be cube root of 8. We don't want to say raised to the power 1 because even if you say raised to the power 1, it is the same thing as the number we have. Then times 4th root of 16, all raised to power 3. Viewers, I've told you that any number raised to power 0 is 1. So we are free to use this number 4, law number 5 to say times 1 divided by, alright, divided by square root of 4, which is using law number 3. So we have already positioned it the way we're going to use it. What is going to be cube root of 4, cube root of 8? Remember how to find roots. What are the square roots, third root, fourth root, fifth root? The way to find it is the same. The method is the same. We are going to divide 8 by the smallest prime number we have. And remember that 1 is not a prime number. And so we are using 2 here to divide to get 4, 2 to get 2, 2 to get 1. Any number that appears 3 times, you pick it as 1. That's how to find cube roots. That's how to find roots. So here, 2 is the number times 4th root of 16. We do something, divide 16, 2, 8, 2, 4, 2, 2, 2, 1. I believe you understand. That means 2 divide 16 will give us 8, 2 divide 8 will give us 4, 2 divide 4 will give us 2, and 2 divide 2 will give us 1, which brings the division to an end. And so, because of the 4th root here, that's what we are looking for. Any number that appears 4 times, we pick it as 1. 4 has appeared 3 times, 4 times here, so we pick only 1 4. But that pick only 1 2, and that 2 is going to be raised to power 3, raised to power 3, times, here we have 1. We have 1 here, but we have started seeing 2, 2, 2, 2, 2. So if you like, you can still change that 1 to become 2 again, raised to power 0. Don't mind that it was 31 raised to power 0 here. We changed it to 1. Eventually we decided to change it back to 2 raised to power 0. Any number raised to power 0 is 1. And so we have just decided to follow the trend of the base here. 2, 2, and we'll now change this to 2. Because 2 raised to power 1 still 2 raised to power 0 will still give you this 1. Then divided by square root of 4 is 2. In this case, the base we have in all of them is just 2. And the law of Indices is telling you, even if the base are 20, they are 10, they are 5, and the base are the same, just pick one number, pick one base. Here we have 2 raised to power 1, there's no number, it is 1. 2 raised to power 1, 3, 2 raised to power 3, 2 raised to power 0, 2 raised to power 1. Pick only 1, 2. We pick only 1, 2, and follow the laws of indices. Strictly, in this case, the value we have here is 1. Write it. When they have times, they say we should add. We put plus on top, plus 3. When we have times again, we add 0, plus 0. When we have divided according to second law, we subtract. We have minus 1. You can see that when we solve the questions we have in indices here, whatever we get will be the index of this base 2. And so, what we have is that the answer is 2 raised to power. We go 1 plus 3 is 4. 4 plus 0 is 4. 4 minus 1 will give you 3. And so so we are going to get 2 raised to the power 3, which is the same thing as 27 as our answer. Remember, if the power is up to 5 or more, you may not raise it, you leave it. You leave it in that index notation. However, because we have 2 raised to the power 3, no. We have 2 raised to the power 3 to be 2 times 2 times 2, which is 8. 8 becomes the last answer. So that becomes the answer. Remember, 2 times 2 times 2 is something with 2 raised to the power 3. Then that is giving us 8 as our last answer. Therefore, this simplification using a set of indices will give us what? Will give us 8. We are now correct if we say that this is equal to 8 after the work. Alright, let's go to question number 2. As I told you, our question number 2 is equation. The work we have to do here will be to find the value of x that makes this particular equation true. That 3 raised to the power 2x is equal to 27 times 3 raised to the power x. What will be the value of x? That we put that value here, put that value here, and what we have on the left hand side will be equal to what we have on the right hand side. That's what this is meant to do. We are meant to solve this question to find out. When we are solving questions involving indices, then what we are going to do is make sure your left hand side and right hand side, both of them have 1 base each. Left hand side here we have no problem. It is 3 raised to the power 2x. But let us find only 1 base here. That means we are going to get 27 is going to be 3 raised to the power 3. I hope you understand it from what we have been working before. That's 3 times 3 times 3 will give you 27. And so we can write 27 to become 3 raised to the power 3. Because we want to make them appear in the same base. Then times 3 raised to the power x. Okay, I think they are not yet in 1 base. The right hand side is still 2 numbers. So we are going to use law of indices and achieve this. 3 raised to the power 2x is equal to, because of law of indices, law number 1, we pick only 1 3. And when we pick only 1 3 here, it's going to be 3 raised to the power 3 plus x. 3 plus x. We have only 1 3 is represented. When we now have 1 number, 1 base on the left hand side, 1 number on the right hand side, that will now say, okay, if the bases are equal, then the indices are going to be equal. And we are now free to cancel out the base and equate indices. Equating indices now, where we have the problem exactly, but the problem here to solve is the value of x. We are going to have 2x is equal to 3 plus x. Addition of like terms will give us 2x minus x is equal to 3. 2x minus x is x. Remember, the coefficient of this x here is 1. And so 2 minus 1 will give us 1. That will give us x is equal to 3. Using to solve question number 3, we have 2 raised to the power 2x minus 5 into 2 raised to the power x plus 4 is equal to 0. Alright. Remember, as we said before, that what we do in equation of indices is to make sure we find out a way to write the left hand side and the right hand side to have the same base. Just as we did in question number 2, before we were able to cancel the base and use indices. This time, however, it's not going to work out here. And so, what we are going to do here is to follow this link. What is giving us the green light, showing us where to continue from, is this 2 raised to the power 2x and 2 raised to the power x. If you look at this, you see that they are similar. And so we try to make this number appear like the one we have in the bracket, so that we can write it as 2 raised to the power x into raised to the power 2. Remember, if we use the law of indices, number 7, to simplify this, we get it back to this. We want to write it this way because it resembles what we have here, and it's going to help us as we continue solving. So we have it here as minus 5 into 2 raised to the power x bracket plus 4 is equal to 0. Yes, we want to find the value of x such that when we put it in here and put it in here, everything here will give us 0. Then we are going to see that we have similar thing in the bracket, 2 raised to the power x, 2 raised to the power x. What do? Let us use a letter to represent 2 raised to the power x. For instance, let us say, let 2 raised to the power x equals to p. Let it become p. Why are we going to use p to represent it? Because we are going to do that because we cannot express them in the same base. What we have there cannot be in the same base. If we do that, if anywhere we see 2 raised to the power x, we are going to call it p, then what we have here will be p raised to the power 2. What we have here will be 5p plus 4. Let us write it. We are going to have here p raised to the power 2 minus 5 times p, which is 5p, plus 4 is going to give us 0. And so this has taken us to a quadratic equation. Remember that we can use many ways to solve quadratic equation. However, because of the content of this particular topic, we are going to use the simplest form of solving this quadratic equation. And so, we want to factorize the left-hand side. The left-hand side is just a quadratic expression. When we have equal to, we have another number on the side, that side, and now call it equation, as we said before. So, open 2 brackets. Open 2 brackets, equate it to 0. Find 2 numbers you are going to multiply. It will give you plus 4. When you add, it will give you minus 5. But before that, factorize p. Remember, p bracket p is p times p, and I will give you p squared. So we have factorized p. Then find 2 numbers, you multiply, to give you plus 4. When you add, to give you minus 5. And the numbers are going to be minus 1 and minus 4. Minus times minus is plus, 1 times 4 is 4. So multiply these 2 numbers to give us plus 4. Adding the 2 numbers will give you minus 5. Go and place the 2 numbers. Minus 1, minus 4. And so it can be factorized. We are now solving this question, this quadratic equation now using factorization method. And this is the simplest factorization method, which is possible when the coefficient of the letter squared is 1. Okay, now we have seen now that p minus 1 into p minus 4 is equal to 0. Then we are saying either p minus 1 is equal to 0. If that is the correct answer, then p is equal to 0 plus 1. Then p is equal to 1. So we have got one value of p, that p is 1. Or, if that is not the one we are going to take it to be, we say p minus 4 is equal to 0. Then p is equal to 0 plus 4. P is equal to 4. Therefore, p is equal to 1 or 4. Remember, every quadratic equation that is not the topic anywhere, but this has taken us quadratic equation. Every quadratic equation will have 2 roots, 2 answers, otherwise referred to as roots. And so we must get 2 numbers there. The question we are working has taken us into quadratic equation, and we've gotten that p is equal to 1 or Recall that we introduced p by ourselves. So we can now say bet p is equal to 2 raised to the power x. That is what we called p from the beginning. So we are going to say, since p is equal to 2 raised to the power x, then we are going to say it means that 2 raised to the power x is equal to 1, which is one of our answers for p. Or 2 raised to the power x is equal to 2 raised to the power 0. Because the only way to make 1 to become 2 is to make it to the power 0. Every number raised to the power 0 is 1. And so this one has become 2 raised to the power 1. Then we have formed simple equation of indices now. If the bases are equal, then the indices are also going to be equal. So we can cancel out the base and say that x is equal to 0. So one of the answers to this question is that x is equal to 0. X is equal to 0. And so, by the time we have done that, we can say, since we have two questions, we can say, we have used p is equal to 2 raised to the power x. So let us use p is equal to, we can use when it is 4. That means 2 raised to the power x is equal to 4. Remember we have used 2 raised to the power x, which is now p, which is our p, is equal to 1. We're now using 2 raised to the power x is equal to 4. If it is not 1, it will be what? It will be 4. And so, what do? Can we express both of them in the same base? Yes, because 2 raised to the power 2 is 4. Then we are going to have 2 raised to the power x is equal to 2 raised to the power 2. And so that is when we are going to solve the equation. If the bases are equal, then the indices are also going to be equal. Cancel out the bases, and then say that x is equal to 2. We've gotten the two answers for this equation. The two answers will be x is equal to 0 or 2. Just note that we cannot have two of them at the same time. We cannot have 2 and 0 at the same time. It's either we use 0, put 0 here, put 0 here, and everything here is going to give you 0, as we have the other side of the equation. Or pick 2 here, put it in here, simplify this, everything you're going to have here will also be equal to 0. The solution to this question number 3, 2 raised to the power 2x minus 5 into 2 raised to the power x plus 4 is equal to 0. The equation will be true if x is 0 or 2. My dear viewer, you can see that actually lots of indices are used in simplification and solving of equations once those expressions or equations involve indices. And when we do that, we get our work to the simplest form when we simplify, and we get the value of unknown if it is equation. Remember to follow me, follow my page, and always watch and share, like and share. Any question you don't understand, if there's any question you don't understand what we have done, please feel free to drop a comment on my page. I will make sure I will reply and give you attention. Thank you very much. See you in our next